Now, what is happening in this is the pendulum that is shown in front of you. So technically, there is a pendulum here, and you are keeping this pendulum like this, okay, like this, and then you throw it like this. So it will start moving like this. Okay. Now this is what is happening in this case. So where is the velocity of this? The velocity of this is tangential to the circle, and this circle is completely horizontal, as we can already see. This is the vertical axis, and this everything is horizontal. uh, we can draw this like this just to clarify it more. So you can call it like this is the x-axis, y-axis, this is kind of z-axis, which is vertical. So this is what is happening there, and the velocity with which the bob is moving now, it is always tangential to the circle. It is always tangential to the circle like this. So it is always tangential, so the bob is moving like this around the central axis. Okay. Now, so how to do these kind of questions, let us see. This is the tension that is acting in the string, because the string is not slack, it is tight. That is why the tension is there. This is the tension T, and this angle will be given to you in the question. So this angle is like it will be given as the string is now making theta degree angle with the vertical, 30-degree angle with the vertical, like that. This is the tension, and this is the weight W. There are so many questions that have been created by IB in this. So one of the question is like from where the centripetal force is coming. So on understanding it, what we see here, that there is the resultant of these two vectors. Like what are the two real forces which are acting on this body now? Well, the tension and the weight are the two real forces which are acting here, no doubt about that. And this is the force which is the resultant of these two. So if you are aware about the vectors, either due to maths AAHL, or you can call it like from the physics point of view. So this is how you can draw the resultant vector. So this resultant vector is actually like whatever it is acting like the centripetal force, and we can say that that is why the body is now moving in a circular motion. Clear? Yes. So that is the first understanding. Now, how to move into further mathematics, and how can we find like about the radius, what is the radius in which it is moving, what are the forces. So this is explanation number one. Now I am moving to the explanation number two. Number one means like this is the first point that I wanted to tell you, that it is the resultant of these two forces which is acting like centripetal. In paper 2 you are getting questions like this, draw the forces, isn't it? So you have to draw only the real forces, and that is why I've told you there are only two real forces, which is weight and the tension. Now let us go for this second explanation. Now what we do, this tension is broken down into two parts. So here we are drawing a vertical axis now, so this angle will be theta, which is equal to this. These are like alternative interior angles. So this angle is theta, that is known now. So the vertical component can be taken as t cos theta, and this will be taken as t sine theta. I hope you know how to create the components of a vector. So let me draw one diagram here. Let us say this is a force F, and it is going like this. Okay, these are the two components. This is theta, so this becomes F cos theta, and this becomes F sine theta. Clear? These are two components. So the side which is touching the angle is cos, and the side which is not touching the angle is sine. So you have to remember accordingly. So theta and the side along theta is cos theta, and beyond theta is kind of t sine theta. So by the equilibrium of forces here, now see, so this bob is now acted upon by two vertical forces, which is t cos theta and the weight W. But is this bob moving in the vertical direction? Is it going up? No. Is it going down? No. So what are these two forces doing? They are balancing each other. Now, this force is the only force which is kind of unbalanced. Well, only if you do not consider the existence of centrifugal. If we consider a centrifugal force, we can say that this is actually equal to centrifugal, and so you can clearly see that the T sine theta will be equal to mv square by r. Okay, so in this we can say the first equation will be T cos theta is equal to W, and point equation number 2 will be T sine theta is equal to mv square by r. Now, as I have already told you that IB does not give you the explanations with the help of centrifugal, so you can either say that this T sine theta is acting like centripetal, or you can say that T sine theta is balanced by the centrifugal. Whatever explanation suits you, you can take up. But anyways, T sine theta will be equal to mv square by r. Now we are trying to solve these two parallel simultaneous equations. So we are going to divide these two. So T sine theta divided by T cos theta will be equal to mv square by r, and the weight is m into g. So t and t gets cancelled out. Sine theta divided by cos theta can be taken as tangent theta. So clearly the tangent theta is coming out to be equal to, like, this m, and this m also cancels out. So this is coming out to be equal to v square by gr. So this becomes one of the equation. Sorry for the weird manner of doing computation here, but definitely it is not right. But I'm just doing it because I'm not into any examination now. So tangent theta is equal to v square by gr. So you do it in a better manner. Okay. So tangent theta is this. And the other thing is that we are now going to square these two equations, and then we are going to add these two. So both of the sides, so this will be t square cos square theta, and this will become t square sine square theta. This will become w square, and on this you can call it fc just for the sake of writing. So it will be fc square. Here we can take t square common. It will become the cos square theta plus sine square theta, which is an identity we know, and this is w plus fc square. So this becomes 1. So clearly t square is equal to w square plus fc square. Okay, so these are the two equations that we wanted to find. So you can find any unknown, the radius in which it is turning, the weight, the centripetal force, or the mass of the body, whatever. These are the equations that we have to use to find any unknown that is given in the question. So t square is equal to w square plus fc square. This is one, and this is another. So this is, I am calling it method 2. Okay, so I was calling this as method 1. This I'm calling it as method 2. Now, after this, I would be giving you another method which is called method 3, which is very, very easy. And before that, we can just take note of this. You can see this, you can watch the video again, you can write, and you can take your notes. This is how we do this. This is actually the right method of doing. But anyways, there is another method that you might have studied somewhere. Let me show you. So I am now erasing this diagram here. I'm erasing this also, by the way. Yes. Yeah, I would be editing this now. Now you see that this angle is given as theta. So what I do, I create this triangle completely. So this is a complete triangle, and this is a right angle triangle. This is 90-degree angle here. Yeah. And I am going to write all the forces on the sides. Like this tension is written on the hypotenuse, so it will remain there. This force W, which is in vertical plane, is written on the vertical side here. And this was the resultant force, or the centripetal, you can say. So the centripetal was the horizontal force. So we will write it as Fc, that is the centripetal. You can call it centrifugal. If you call it centrifugal, only the direction will be different. Like it will be shown like this. Otherwise, it will be shown the other way. Otherwise, there is no difference now. So this is Fc, this is T, and this is W. And this angle is also given as now theta. So if you draw this kind of triangle, how easy it is for you to find these two. expressions. Now just see, in this triangle the tangent tan theta is equal to fc by w. Very well. You can also write what is the sine theta, fc by t, what is cos theta, w by t. And when it comes to the right angle triangle, there is a Pythagoras theorem also. You apply the Pythagorean theorem and it will become t square is equal to fc square plus w square. So hypotenuse square is equal to the base square plus height square, and this is clearly equal to this. So if you do not want to go for this much of the mathematics, this becomes another alternative for you, which can be applied, but with the condition that it has to have a right angle triangle. Only then it will become easy. Otherwise things will become very difficult. So we do not want to apply this method to any other diagram, but only in this case we can do this. So this is the right angle triangle here, so it becomes t square is equal to fc square plus w square, and tangent theta is equal to fc divided by w. So this is the third thing. We are going to do the similar topic in the laws of motion also, and there we are going to learn everything about the strings and the equilibrium of forces, and I would be teaching you the same topic again there. So this is kind of connected, so beware about that. Okay dear students, so in this video we have learned about the conical pendulums. So we would be doing one question also in the next video. All the best, bye, see you there.